Okay, we're talking about the Mathematics Through the Ages benchmark that is due at the end of the semester. So I wanted to share some samples of what we're looking for. This one is Mathematics Through the Ages, and it's done like artwork. I really don't care how it's done per se. It's nice to have a kind of gimmick sort of process. This one, as I mentioned, uh, begins with a table of contents and a key. This is doing number systems, the symbol for algebra, geometry and trig, statistics, probability, calculus, and discrete. And then as we go through this particular student's work is starting at the beginning and going through the process. It's not going by pieces, meaning it's not going by number theory and then or number systems. It's not going by number systems and then algebra and then geometry, trig, statistic. It's not doing each one of those individually. It is going through them united. So here we see the Lubamba bone, and we have the tick marks and the Egyptian numerals and the tick marks. And then we have Sumerian clay tablets, and you'll notice that has some algebra and some trig and geometry, which it does, so that makes sense. And then we see some more algebra and geometry and algebra and geometry. And then as we continue along, this student pulled out the Lubamba bone, talked about it, uh, discussed where it was found, all that sort of stuff. This is kind of the previous idea, right? This one was what we were using before. What you're going to be pulling out is a particular person and talking about their works. So you may want to go for a while with these. They also pulled the Plimpton, continuing along this idea of the timeline. And you see a bunch of geometry, and then you see the Archimedes palimpsest, which is both geometry, pioneering what would become calculus long before calculus, and then pioneering discrete, which again isn't even anything yet. So, and then wherever it's appropriate, you're going to try to fit in the person that you're doing. You're looking for new research on a particular person. So these are the ideas. The timelines will be very consistent. Your timeline should be along the same idea. It may not pull out the same, like you may not talk about Thales or Meletius. You could, but you may not. You probably are going to mention elements. That's just way too big. Pythagorean theorem, you'll probably mention. Those are big ones, so everyone will probably mention those. And then the palimpsest here of Archimedes. And you may or may not choose to pull out information about Arithmetica or the 9 chapters or Algebras, Al-Khwarizmi's works. But you really should do Al-Khwarizmi. Like, I mean, that's foundational to algebra. And you'll see that this just goes along with the timeline as we progress through the ages. You again won't be pulling this out. You'll be pulling out your person and talking about details about them. So you'll give me the basics of their life, and we'll kind of walk through that at the end. And you'll see how this has just continued to go all the way through to, let's get over here, continuing the process till we get into Florence Nightingale's polar diagram, one of the most beautiful. And then we get into modern mathematics, and you'll notice these are both statistics and probability and discrete, calculus, discrete, and we made it up through Terence Tao. And I think that's, oh, then they pulled out. Okay, good. That's where that one ended. I want to show you another way to do that because this was just one way. I have another one here. Here we go. So this is another student's work. Oops, start here. There we go. And begin. Okay. So this is another student's mathematics through the ages that had taken a different approach. So this one, again, they give the breakdown: number systems, algebra, geometry and trig, statistics, calculus, discrete. And they're actually giving, in their preview, they're giving some of the specifics they're going to pull out and talk about. But they broke it down to talk about the study and development of numbers and number systems. So this is where they talk about the Ashango bone, not the Lubamba bone. And there is some incorrectness. It's not the oldest artifact. The Ashango bone isn't. The Lubamba bone is, but they talk about some of this. And it's got a timeline in here, but it's really talking about the development of numbers. And you'll notice that they come all the way through talking about chimer zero and other stuff. So this is the number system. And where we have about 683, they could have continued, talked about Liber Abaci by Fibonacci, because that's where we actually get the Hindu numbers. Did they? No, they didn't. Okay. And that's where we get the Hindu numbers that we use in English or Latin. And then after they do this, and they pulled out specifics, which is beautiful. Then they go into some other concepts of numbers and number systems based on today. So the binary number system, when it was created, and how it's used today. So this is all still part of the numbers. And then they go into algebra. So now they're talking about the study of algebra, the beginnings with Babylonian texts. So they've already talked about Babylon, but they're again talking about it. And the Rhind Papyrus, again, was previous, but now it's here again. And then they talk about Al-Khwarizmi and some more continuation on algebra through Niccolo Fontana and Rene Descartes. So definitely the continuation of algebra. They pull out a couple people. Again, we talked how your pullout will be a little bit different. And then they talk about geometry and trig. Again, they've talked about Euclid. They've talked about Pythagoras already. They're just continuing that process now, talking about the Greeks, but now they're taking it the next step. And they continue talking about, we begin with the Greeks, and then it goes into China and other places as they continue to progress, all the way up again through Rene. He did do a lot, so that's not a surprise. And then pulled out some stuff about particular people, and then moves on to statistics and probability. And again, starts with when we first start to really see it start happening, was over here, and then they pull out, they didn't pull out some of the beginning people, but they did pull out Gauss, Bernoulli, Nightingale, with her chart, which is one of my favorite charts of the top three, in my top three. Carl, Pearson, and then Fisher, which I'm not surprised they're talking about Fisher. That's a very common statistics one. They pull up Jacob, Bernoulli, law of large numbers, of course, and then they pulled out Gosset, which is a good choice too. Then they do calculus. And of course, to talk about calculus, long before you get to people like Newton and Leibniz, they started with Archimedes. They continued through Kepler, Fermat, Descartes, and then they get into Newton and Leibniz, and then even passing them. So we have to pass after the development, where we're actually fine tuning and getting calculus that you guys know. You have Jacob again, and then Euler. And they pulled out Isaac Newton, and they pulled out Euler, which are great, wonderful choices to pull out. And then we get into the study of discrete mathematics. And they start with Aristotle and other Stoic philosophers, and then they begin into combinatorics with Pascal and De Moivre, And they go into Leibniz. And they continue with Boole and then Frege. Interestingly, they did not, I'm looking at it now, they did not actually mention, go back. They did not mention Euler, it doesn't look like, which that's fine. And then they pulled out Boole and they pulled out Frege, okay. And then their references. So references don't have to be its own slide. In fact, I prefer that it's in the actual slide notes or speaker notes. Now, here's two examples you've got to see. I wanted to actually reiterate what we're looking for. So what I'm looking for is, I'm looking for something that's not on Wikipedia about a particular mathematician and not on MacTutor about a particular mathematician. Now, there's a lot more on MacTutor than there is on Fibonacci usually, or on Wikipedia usually. It's not saying that there's not a lot of stuff. And you'll notice everything's referenced. And that holds true with MacTutor. There are references. You can show all of their references. So you're going to need to reference your stuff. One of the things I want to point out here, if I go to, where is it? It's Liber Abaci, the Book of the Abacus. Oh, there we go. Okay, so Liber Abaci, published in 1202, after Fibonacci's return to Italy, and who he dedicated the book to. The book was widely copied and imitated, introduced the Hindu-Arabic place value decimal system and the use of the Arabic numerals into Europe. And it goes into talk about that a little bit, but that's all it really says here, okay? And then if we go to here, and we go down to Liber Abaci, it says here that, he basically introduced known as the Hindu-Arabic numeral system with 10 digits, including a 0 and a positional notation. The book showed the practical use. Okay, but what they don't tell you is that he didn't actually, Fibonacci didn't actually think of 0 as necessarily a number like 2 or 3. He didn't feel that it had a different use. And when you, that's going to be, there we go, let's go here. So in MacTutor, there's an article called 0, and it's on the history of 0. And in there, they specifically share that in Liber Abaci, Fibonacci described the 9 Indian symbols together with the sign 0. The sign, like it was a positive or negative, for Europeans in around 1200. But it was not widely used for a long time after that. And it is significant that Fibonacci was not bold enough to treat 0 in the same way as the other numbers. He speaks of the sign of 0, not as a number itself. He knew it was a place value. So 1202 is different than 122, right? He knew it had more work, more abilities, but he didn't treat it as a number like 3. And so that's not in either one of this. That doesn't discuss that in here. It doesn't discuss it in here. They do say including a 0, but they don't actually say that he didn't treat it like a numeral. He treated it as a placeholder and as a sign, meaning it had certain properties that the other numbers did not possess. So that's quite interesting. And that's something that could be added. to this or added to this up here. So what I want from you guys is as you guys pull out your special pullouts along with your timeline is going to be something like this. Not necessarily this particular piece, and I don't want you to do Fibonacci unless you have something new to add to it. So your first slide pullout might talk about the person, whoever that particular mathematician is, a breakdown of their name, what you see here in that introduction. And then your next pullout, and you can have that at different places. They don't have to be all together. You could genuinely pull out a little piece of this person and then do some more timeline and then pull out maybe the biography, and you kind of talk very similar to this. You don't necessarily have to put the paragraphs in the PowerPoint, but you might have the paragraphs in your speaker notes because you're going to be saying these things, but you're not necessarily going to list paragraphs in your PowerPoint because that's not appropriate. You'd have bullet points or whatever, but you would talk about their biography. And then you would pull out like their book. In this case, we were talking about Liber Abaci. That's what we found something new on. And you would say, this is something that's not in Wikipedia, MacTutor, on their biography page. This is what we found. And you would have that here. And then you might pull out something like the legacy and then, or the sequence or something else that they've done that you may not have added to. It might be the same stuff that's in here, which is okay. Then you might say, okay, here's their legacy, or here's their what they're leaving for everybody else, or influences. That might be a better word for it. The influences that they've had on other people and on things that we use currently. And then, of course, you could list their works either up here or down here. I don't really where you list their works, but it should be somewhere either in the before you get to talking about a particular work or in the biography, but you should list their particular works. Sources, you're going to have the sources of whatever you found here, right? That you're just translating and putting in your own words. You're not word for word copying this, but you've summarized. So those sources become your sources. That's fine. But you're also going to have a new source of whatever new information you discovered up here or about wherever. And you may have more than one. You may have found a bunch of new stuff. That's okay. You're going to share those sources in the back in like a final slide, your ending slide in your speaker notes, because your speaker notes can hold a lot more references than actually your slide can. So please don't put it on the slide, but do put it in your speaker notes. All right, I think that gives you a good setup for the Mathematics Through the Ages benchmark, and I'll get this posted as soon as possible. Have a good day.